In section 9.2, we look at estimating a population mean. Now, similar to what we did in section 9.1, where we estimated population proportion, under 9.2, we consider point estimate and then interval estimate. Now, take for instance, we want to find the mean height of undergraduate students in CMU. So we take our population to be undergraduate students in CMU. Now, with our aim of finding the mean height of the students in CMU, you know it will be difficult to take the height of every single undergraduate student and then find the mean of their heights. So what we can do is to take a sample and then find the mean height of that sample. Now, if we find the mean height of the sample and we use whatever the result is, the outcome, to make judgment on the population mean, then what we are doing is called point estimation. So a point estimate of the population mean, mu, so remember the population mean is denoted with mu, is the sample mean. So we estimate the population mean with the sample mean. And when we do that, we are doing point estimation. Alright, so this is similar to what we saw under section 9.1. Then we go to another level higher, where we just don't want to estimate a single value, because if another person takes another set of sample, or even the same person who probably got the first result for the sample mean takes another sample, it is very possible that that sample will, the outcome, the sample mean will be slightly different from the initial sample mean. So with several different samples taken, there will be different outcomes for the sample mean. And to be safer, we can consider having a range, okay, an interval, to say that, okay, the population mean is likely to fall within this interval. Now, when we do that, we are doing interval estimation. So similar to what we saw under 9.1, we make a confidence interval. Okay, so we come up with a confidence interval. Usually we call that a 1 minus alpha times 100% confidence interval. So some of those instances you can see will be like the 95% confidence interval, or the 90% confidence interval, or the 99% confidence interval. So this number that I mentioned, 90%, 95%, 99%, those are called the confidence levels. So for instance, with a 95% confidence level, what that means is whatever confidence interval I come up with, the assumption is that if I should take my samples 100 times and I make an interval, then 95 of those intervals that I'm coming out with will contain the true population mean. Okay, so because 95 out of the 100 will give me an interval that will contain the population mean, then we call that a 95% confidence interval. So generally, confidence interval is given as the point estimate plus or minus the margin of error. So if we are estimating the population mean, then that will be x bar, which is the point estimate for mu, plus or minus t alpha over 2 times s over square root of n. So at this point, we are seeing something new, right? So t alpha over 2, what is that? So I'll be speaking more about that, but then we are familiar with what s is. S is the sample standard deviation, and then n is the sample size. Now coming back to t alpha over 2, that is called the critical value. Okay, so t is a distribution, and we are seeing this distribution for the first time. It's a distribution, and we find that distribution, well, the shape of that distribution is similar to the standard normal distribution. All right. So before we go on, I will speak briefly about the t distribution and how important it is over here. Now in 9.1, we used the standard normal distribution, which we denote with Z. So over there we had the critical value to be Z alpha over 2. But in 9.2, we are using the T distribution because this is what is appropriate when you only know the sample standard deviation, and then you have a small sample size. Okay, so by definition, the T distribution is given by this relationship where you have x bar minus mu over s over square root of n. Okay, as you see in the picture. So we see that this T follows a student's T distribution. That is the full name, student's T distribution. But usually we just say T distribution with n minus 1 degrees of freedom, where x bar is the sample mean and s is the sample standard deviation. Now, let's learn about some features of the T distribution, some properties. So the T distribution is different for different degrees of freedom. Okay, so the degrees of freedom is also an important aspect of the T distribution. So you will have different distributions coming out for different degrees of freedom. And then the T distribution is centered at 0 and is symmetric about 0. So it is similar to the standard normal distribution, but then there is just something slightly. Okay, so it shares the same midpoint or center with the standard normal distribution, but each spread is different from that distribution. Now the area under the curve is 1, and then as the T increases or decreases without bounds, the graph approaches but never equals 0. So, and then as the sample size n increases, the density curve T gets closer to the standard normal density curve. Okay, then this result occurs because as the sample size n increases, the values of S get closer to the values of sigma by the law of large numbers. Well, you can find this information in the PowerPoint slide that I provided on page 28. Okay, page 28, which talks about the properties of the T distribution. So in the picture, the very first picture on your left, I show the T distribution. I showed 3 plots, where the first one, which is colored blue, okay, the curve with the blue lines is a standard normal distribution. Then the 2 other curves colored red and pink are T distributions, where one has a degree of freedom of 14 and then the other one a degree of freedom of 4. Now I say 14 because we have a sample size of 15 and degree of freedom is n minus 1. So 15 minus 1, that gives you 14. And the other one as well, 5 minus 1, that gives you 4. So you can see that these two, we have 2 different T distributions here for different degrees of freedom. And their shape, they kind of have the same bell shape as the standard normal, but then it is not the same as the standard normal. Now, I have an example of T distribution where an area is shaded for you. So that when you see T sub alpha, what that means is that the T alpha is a critical value where the area to the right is alpha. And also, if you see T sub 0.2, it means that you have a T distribution with the area shaded to the right being 0.2. Alright. Now, just like how the standard normal distribution has values put in a table where you'll be able to locate a critical value from a statistical table, the T distribution also has a table. So a typical T distribution is given such that for the first column you have the degrees of freedom, and then for the top row, okay, the row header, you see various area in the tail, okay, and then in the bigger space of the table you see the areas that are associated with those various degrees of freedom, and then the area in the right tail. Okay, so the table, you read it paying attention to the area that you are given in the right tail. So we'll see how this works as we move along, as we work through the practice problems, which I will show in another video. So coming back to the confidence interval, the 1 minus alpha times 100% confidence interval, remember, it's an interval, okay, which has a lower bound and an upper bound. And whenever you come up with that, the idea is that whatever the true population mean is will fall within that interval. Okay, taking into consideration your confidence level. So with a 95% confidence level, it means that when I construct my interval 100 times, 95 of those will actually contain the mu within the interval. So the lower bound again is given as x bar minus the critical value, which is t alpha over 2 times s divided by square root of n, and then the upper bound x bar plus t alpha over 2 point s divided by square root of n. And remember, what the term that you have on your right is the margin of error. So margin of error is t alpha over 2 times s over square root of n. So this just summarizes what section 9.2 entails. Thank you.